Hi, my name is Ali, and today I'm going to be making and testing different resistors in a voltage divider. So, a voltage divider circuit is just, in simplest term, a circuit that looks like this. They can be more complicated. You could have resistors in series and parallel, but then you could just always simplify it into one resistance um, simply by adding them if they're in series, or by doing the parallel, like combining parallel resistances. There's an equation for that. So this is the equation that models this voltage divider circuit. As you can see, V out will always be less than V in because R2 over R1 plus R2 will always be less than 1. So in my video, we're going to be dividing the input voltage by half, and we'll always have V out equal to half of V in as long as R2 and R1 are equal. So what effect will having a really small or really large equal resistor have in the real world? Because we know ideally it wouldn't matter what resistor values we choose as long as they're equal. V in would be divided by 2, like they could be a million ohms or like 2 ohms. Ideally, it would give you the same voltage output. But we know the real world doesn't always follow ideal situations. So we will be testing this, like the effect of small and large resistors in a voltage divider configuration. So if you want to follow along, you'll need pairs of identical resistors, a breadboard, or a soldering iron. I recommend a breadboard because it's much easier to use, a multimeter, and wire, and a known voltage source. But as long as you have your multimeter, you'd be able to determine it. But it's always nice to just know what your voltage source is. So these are the resistors we'll be using: 10 ohm, 100 ohm, 1000, 10,000, 100,000, and 1 million. They're logarithmically scaled. And just as a bonus, we're going to be seeing what happens with a 0 ohm resistor. So comment your prediction below. What do you think will happen if we put 0 ohm resistors in the voltage divider? Hello, this is just showing the process that I'll be doing for all the resistors. Right now I'm using the 10 ohm resistors. I have them set up in a voltage divider configuration, and I have the 5-volt source right here, and the ground source is connected to the negative terminal here, and this is the multimeter I'll be using. So let's see what happens. We plug in the positive voltage source. Now there's current flowing through. Let's turn our voltmeter on. So first, you can see the voltmeter reading from here. So first, let's see how much voltage there is. So it's around 4.4, as you can see there. So 4.41, and the reason that it's not 5 volts right now, one second, why can't I get this? Yeah, so it's around 4.5-ish volts, and the reason for this is because the wires have like resistance as well, and there's power loss due to that, and that's why it's not like the 5.8 volts and 5.08 volts that we saw from the beginning. So now let's test out how the 10 ohm resistor works in the voltage divider. So I'll put my positive probe right here, negative probe right here. Right now we can see, so that's around 2.26, so around 2.25 basic. It's staying steady at 2.26. So those are our two values for our like initial voltage drop across the two resistors. It was around 4.47, 4.45, and our voltage divider, it divided it and gave us a voltage of 2.26, and I'll be repeating this process for all the resistors, and then afterwards I'll be making one for the 0 ohm resistor. So I'd like you guys to think about what's going to happen with the 0 ohm resistor. Do you think it's going to divide the voltage or what? Comment your thoughts down below. Hi guys, I just finished testing all the resistors, and as you can see, they don't all give you the same values, but there are some patterns we can notice. So as we go on to the higher resistors, the voltage basically evens out to like 5.10, and it just stays at that after around 10k. It just stays at that. And the voltage division, it kind of follows a bell curve like this. As you can see, it's smaller and it becomes larger and larger, and then it becomes smaller again. So I think we can conclude that around the 100k to 10k range is good if your initial voltage is around 5 volts. Then you should be using resistors in this range to get optimal voltage division, because if you start to go above that or too far below it, then it starts varying by a lot. As you can see, the 10 ohm case, the voltage across the resistors is pretty low. Well, not pretty low, but like it's lower than what it should be. It should be around 5 volts, but it's 0.5 volts lower. And over here, this should be around 2.5, and this is around 0.25 volts lower. And if we go on the other end, the really large case, the voltage across it is 5.10 volts, but the voltage division is basically, it stops working. It doesn't follow that relationship or that equation that we talked about in the beginning. This one doesn't follow it. So now we're going to be testing the special case. So think about that, and it'll be coming up right now. Hi everyone, so now I've connected the 0 ohm resistor in the voltage divider configuration on my breadboard, and I want you guys to notice what happens as soon as I plug in the positive voltage. As you can see, as soon as that happens, it shuts off. Now the reason behind this is because this is simply a short. The 0 ohm resistor just acts as a wire. So basically what we're doing here is we're just connecting the 5 volts to the ground, and that's not allowed. See, I can prove it to you right now. If we were to just take this out and just take our 5 volt pin and just put it in the ground, as we can see, the same thing happens. So basically what we can conclude here is that the 0 ohm resistor will not work as a voltage divider because it just acts as a short.